Alright, so in this example we have a cubic, so we have to kind of, or cubed root, cubed root. That's that horizontal S shape. So its critical points would be -1, 0, 0, and 1, 1. And again, we got to think about mapping-wise what's going to happen here. So it looks like all of our x values are going to be 3, subtract 3 from them, and all of our y values are going to be subtract 1. Okay, so horizontally, it's going to move to the left, left 3, and vertically it's going to move down 1. Okay, so where'd the vertex go? Where'd that critical point go? Well, we started at 0, we moved over 3, so 1, 2, 3, and we moved down 1. So it's at -3, -1 now, instead of at the 0, 0. And it doesn't look like we actually have any compress or stretch. We're not really multiplying the y's by anything. We're just subtracting both cases. Okay, so where would our new points go? Well, let's see. In this case, x minus 3. So -1 minus 3 is -4. 0 minus 3 is -3. And 1 minus 3 is -2. And then for the y values, it's just -1 minus 1. So it's -2 for that point. So -4, -2. Let's see, -4, -2, a little bit lower. Then this one we already did this. So 0 minus 1 is -1, which is already on our graph. And 1 minus 1, which is 0. So we got -2, 0 for the other point. And then we just need to remember that it's a horizontal curve, not a vertical one. So I'm just going to make it horizontally stretched through that. Alright, so what is our parent graph? It is an absolute value. And its critical points, it goes through -1, 1, 0, 0, and 1, 1. And what's happening with our mapping here? So the axis is x minus 4, so that means we're adding 4 to the x's. So we're going to move it right 4. Let's see, vertically we're going to move it up 2, but we also have that negative out front, so there's a -y plus 2. So the y values are going to be opposite, and then we're going to add 2 to them. So, but vertically it's going to shift up 2 units, and then it's going to have what we call a reflection. So it's not really stretch or compress, but it'll reflect across the x-axis and have an opposite y value before we end up adding the 2 to it. So where'd the vertex go? Where'd that critical point go? So it starts off at 0, 0. We go right 4 and up 2. Puts it right about there. So it must have moved up 4, 2. And let's see, so we'll add the 4 to all the x's. So -1 plus 4 is 3, 0 plus 4 is 4, 1 plus 4 is 5. And the y's, so that would be -1 plus 2, which puts me at 1. So 3, 1. So going down, that's a good sign, because that's what I expected to go, is face down. Then I want -0 plus 2, which is 2. We already figured that it was at 4, 2. And then I want -1 plus 2 again, which puts me back at 1. So on that side should be that ordered pair there. And I just have to sketch reasonable approximation of what the parent graph should actually look like. The very last thing I want to address under transformations are what are called non-traditional transformations. So what if we're asked to manipulate something that's not quite a parent graph? How would one go about doing that? Well, it's actually a very similar skill to doing the parent graphs. We just have to identify ordered pairs, move those around, and there we go. So in this graph right here, we just kind of look at the ordered pairs we have. Let me make that a little bit bolder. So we have that at 4, 0. Here we have it at 3, 4, 1, 1, 0, 3. I'm sorry. Yeah, 0, 3. That's right. -2, -3, and -4, 0. Okay, so in each of our little transformations, that's what we're going to manipulate. So here we've got x plus 2, but it's on the inside. So mapping wise, that would mean all of our x values are going to subtract 2, and the y's would stay the same. So in other words, I just want to move left 2 units. So instead of being at 4, 0, I'm going to go to 2, 0. Instead of 3, 4, I'm going to go over to 1, 4. 1, 1 is going to go over to -1, 1. 0, 3. Again, I'm just going to the original point and literally just counting 2 to the left. -2, -3, 1, 2 right there, and -4, 0 puts me there. And then I'm just going to connect these dots, and it should look like the same picture, just shifted 2 units over. Right below this next one, f of x plus 2. Okay, so what is that going to change? Well, the plus 2 on the outside means we're affecting the y values. So all of my y values are going to be 2 units higher. And then I can just do what I did before, go point by point and count 2 up. So 4, 0 would be 4, 2. 3, 4 puts me at 3, 6. 1, 1, again, count 2 up. 0, 3, count 2 up. -2, -3 puts me at -2, -1. And -4, 0 puts me there. And then I just got to connect my dots, and it should look like the same picture, just shifted up 2 units. Alright, very last one of these. If we put the 2 on the outside, that is changing our y values, and that's going to make our y values twice as big. It's a vertical stretch. So I'm just going to go to each of my points and make the y values twice as big as they originally were. So starting at 4, 0, well, 0, 2 times 0 is 0, so that point doesn't change at all, actually. 3, 4, the 4 becomes an 8. It's now 3, 8. 1, 1, so that 1 becomes a 2. 0, 3, the 3 becomes a 6. -2, -3, I'm going to be off the screen here. -2, -3 is now going to become a -2, -6. And the last point, -4, 0, again, if I double 0, I just get 0. So there you go. And then I'm going to connect these little line segments together. And it should look like the original graph, just someone has kind of pulled it further apart, stretched it out, and there you go.